Hello, y'all. We're back again, and yes, we're wearing the same shirts. We recorded 2.1 and 2.2 on the same day. Um, we
We
talk,
would never. We
you
would never.
never know. Yeah, we record them back to back. You don't necessarily watch them back to back. So
Or you might if you're watching all the videos the night before the test.
that's exactly where you might be doing it. So it's true. We're gonna fake you out and change shirts, but then we say, you know what? It doesn't really matter. Nobody cares about what we do. So I'm Corey,
I
and this.
didn't change drinks though.
Yeah, she is now drinking Starbucks. And I'm not drinking anything right now. I finished my bottle of water, and I'm going to be thirsty by the time this is over. So we're going to talk about the algebra of functions. So let's just get this show on the road. Okay, function arithmetic. Just like numbers and anything else in algebra, you can add, subtract, multiply, and divide functions. So we're going to do that. A couple examples here. And we have two functions. We have f of x equals x squared plus 5, and g of x is 4x minus 1. Yes, okay. And so when I go to do, what we're going to do is f of 2 and plus g of 2. Well, we did this, we did f of 2 in an earlier section where we substitute the number in. So what I'm going to do here is I'm going to substitute 2 into f of x. So I'll have 2 squared plus 5. And if I do that, that's going to give me f of 2. Well, to that, so I'm going to put this in parentheses here. That's f of 2. And to that, I'm going to add, let's see here, 4 times 2 minus 1. Now I got to do lots of great arithmetic. So 2 squared is 4. That first one's going to be 9, right? Miss Young's more worried about her Starbucks. So
I am not. You're just doing such a good job.
And
I was going to comment.
Yeah, that's like the quietest you've ever been, minus 7. So all of this adds up to a big fat 2.
Listen, I was going to comment. He added some parentheses into this problem that weren't there in its other form, f of 2 plus g of 2. And he surrounded f of 2 in parentheses, and he surrounded g of 2 in parentheses. And he does that to help with order of operations. That's why he's doing that.
Yeah,
okay?
and it also kind of like helps me know that I did each part. Like that part is actually f of 2. Okay? And then this part, let me do blue. That part is g of 2. And I'm making it harder than it has to be. But in case you had any ambiguity, you're going to just do each function. I could have done each function separately and got 9 and 7 separately and then added them. Oh, wait a second. No, I wanted to add them, so it should have been 16. Silly. Thanks for, so you were more concerned with your.
Well, I like that you just scribbled that out. There's an eraser.
Oh, there's no eraser. Well, there is an eraser.
No, there is.
But that's a legitimate cool thing. Hi, I moved you over. So you can just do that. All right, that's cool. So, all right, what about f of 4 minus g of 4, which is exactly, now I actually want to subtract versus adding because I did that wrong in the previous problem. So let's see, what's 4? And I probably need to clear some ink because I put too much there. So let's work this problem here. Okay. So I'm going to put 4 in now. So I have 4 squared, which again is my favorite game from the playground, plus 5. And then to that, now I'm actually really want the parentheses are going to be super helpful here because I have to evaluate this whole thing. And if I don't do this correctly, I'm going to get the wrong answer. So 4 times 4 minus 1. So this parenthesis with this parenthesis is actually important now because I am subtracting. Okay, I have to do I have to find g of 4 in its entirety. And if I'm a little sloppy with my arithmetic, I'm bound to get the wrong answer. So I'm going to get 19 for the first set of parentheses. And what am I going to get in the other one? 15?
16 plus 5 is not 19.
No, it's 21. It's not. Yes. No, I don't want to erase it all. I just want to erase the 19. Yes, it would be, what did I say it was? 21?
21.
Last time I checked, it should have been 21. Yeah, that's right. Thank you.
You're very welcome. See, I'm paying attention now. I put my Starbucks down.
Minus 15.
Minus 15, yep.
So the answer is 6, if I can do this right. How many of you are sick of this already? All right, Miss Young. Miss Young's already sick of it. So yeah, and there's only one person I'm talking to. So I'm assuming that I better move on and show you a slicky boy way of doing it. I'm ex-military, so I sometimes military pops out, and slicky boy was the term we used for somebody who would try to steal your stuff in the military. So, but he was also really smart because he never got caught for some reason. Okay,
he was slick.
He was slick, right? So I'm going to show you a slick way of doing this. Now I could have actually done all the work, and we're going to remember the numbers I had a minute ago. But we're back to the Inspire, and we're going to make a new document. And this time, earlier we did a graph. Hey, that page looks familiar. We don't want, when we make a new document, we're going to choose no and throw away the old work. If we pick up somebody else's calculator and they were doing something, they may be crazy, so I'm going to throw their stuff away. And maybe I don't need that. Now, if I wanted to, you can save it on your calculator, but we'll talk about that on another day. So I'm going to choose this away. Before we did graphs, now we're going to use the calculator as a calculator. Imagine that. So I'm going to choose number 1. And now I am like on the home screen of the 84. So what I want to do is there's two functions here, f of x and g of x. And there's a way to put them in the calculator. It's called menu actions. Oops, sorry, I hit the wrong menu. Escape.
Numerical derivative, that's not what we want.
No, I want menu actions, and I want to do what's called define. Now, I could have actually typed the word using the letters at the bottom. That's why the letters are there. Okay, so I could type the word define, and then I could just type f of x, and I'm using my computer keyboard, but you would be using the buttons on the bottom of the screen. F of x equals x squared, and I could have I hit the x squared button, or I can do caret 2, whichever, plus 5. And now the calculator knows what f of x is, and I'm also going to define, and notice if I type the word define, it comes up, g of x equals 4x minus 1, and that's also done. So both of those functions are now in the calculator. I have to tell the calculator what the equations are, and if I just type, now if I do f of 2 plus g of 2, hopefully we get the same answer we had a moment ago. We had 16. Yes, I remember because I messed up and I got it right after I fixed that. Okay?
Yep.
And now I can do f of 4. So when somebody has, if I asked you this question, you would be really, and the issue with parentheses is completely resolved by the calculator. I think I had 6 a minute ago, didn't I?
Yep.
Okay. So now now imagine what would have happened if I had to do all this, the arithmetic, and again, I might add my parentheses, and then I had to multiply. And then in the last problem, I had to do all the arithmetic and then divide the answers. Well, I'm just going to do f of 1. How many of these do you think I should put on the test, Miss?
At least 12.
At least 12 of these?
Yeah.
The next one would have been 18, and you could check my math. That would have been, let's see, if I plug 1 in f, it would be 6
times 3, yeah.
Yeah, that would work. And then if I had done f of 0 divided by g of 0.
5 divided by negative 1.
5 divided by negative 1, I'm getting negative 5. Okay. Wow, super. I'm probably not going to put 12 of these on the test. Okay.
But they're really hoping you do.
Yeah, they're really hoping that I do now. Okay. Sorry. I'm not stupid. I'm not going to show you a trick and then like ask you to do it. All right. Now they also give you function notation in slightly different form. Then mathematicians are great. If you are a lazy human, you might want to become a mathematician because we try to do things the shortest way possible. We like to be lazy. So they, instead of writing 2 x's, they say f plus g of x instead of f of x plus g of x, because that's a whole nother x I have to draw.
Right. So hard.
So hard for me to do. Same thing with the subtraction, multiplication, and division. So if you see the f and the g in the set of parentheses, it's just adding, subtracting, multiplying with the 2 functions.
Yeah.
Okay? Now, I have a workaround so that you can't just throw everything in your calculator. I'm just going to leave it in terms of x. Oh, I shouldn't do it.
You're
That,
ridiculous.
that was ridiculous. So you can't do just X in the calculator, okay?
Yeah.
So if I do this, and trust me, guys, I'm not like I just play a dumb person in real life. I'm not actually a dumb person. Okay, I know what to do, so whatever. All right, so what this means is that I'm going to take these two expressions and I'm going to go back so that I grab my pen and actually write this time. What it means is I'm taking the expression for f of x, and to it I'm adding the expression for g of x. And we're going to do it with variables. And how do you add variables? You combine like terms. You've been doing that since 8th or 9th grade. So what I'm going to do is add 4x, I'm sorry, not 4x, whatever, scratch it out.
While he's writing this line, instead of reading it to you, I'm going to just throw out there that you could also have seen this in the f of x plus g of x notation like you saw on the previous slide. So it isn't that like one notation is used for numbers and one notation is used for x's. They're interchangeable. You can see them either way.
Exactly.
So now he's combining like terms. So he's going to write his x squared first, and then he's going to combine 4x and 1x to get 5x. And then he's going to tag along the -3 because the -3 doesn't have anybody to play with.
Yep, and there's my answer. Addition's easy. That's the easy one because you're combining like terms. You have to worry about it. But watch out for the subtraction. Why I put the parentheses there is for the subtraction and the multiplication. Okay, so for this guy, for the subtraction problem, I'm still going to do what I was doing. I'll have x squared. It's fine for the first one, but still it doesn't hurt to have it there. But when I do this minus, it'd be x minus 3. Now I got to distribute the minus sign again. We have that same problem we had a moment ago or had earlier on. So do you want me to write the next intermediate step? So
I don't think you need to. What's going to happen here is you're going to subtract the x, and then you're also going to subtract the -3. So just want to remember that if you're doing this and you're working a subtraction problem, that everything that comes after that parentheses or that subtraction sign in that parentheses is going to change signs, right? So x squared didn't have anybody to play with. Positive 4x minus x became positive 3x. I'll just fix that for you. And then minus a -3 becomes +3.
I didn't mess up.
I didn't see it. You just wanted me to finish it. That's all.
That's right. I wasn't done. So what do I have to do when I multiply?
You have to distribute.
I have to distribute. Yeah, I have to do x squared times x, and then x squared times -3, and then 4x times x and 4x, but whatever. You've done this a million different times, I hope.
So what he's saying is you have to distribute x squared to the x and x squared to the -3, which is this first part that he's writing right now. And then you have to distribute 4x to the x, and you're going to get 4x squared, and then 4x to the -3, and that's going to get you your -12x portion, right? So you might have heard this called FOIL for first, outer, inner, last at some point, but really it's just a double distributive property. And then combine your like terms.
Let's see if I can do this one right.
Let's make fun of him if he doesn't.
Wow. You know what? It won't hurt my feelings because I can't hear them.
Truth.
I think I got it right.
Perfect.
Yay.
Notice how he's modeling a really great strategy for you here by boxing his final answer and making sure he's staying really organized within his work.
Even if my handwriting isn't perfect.
Yeah.
It's not about
nobody. It's very good on this slide.
Yeah. So the last one is division, and we're going to address this a little bit more later on. My f of x is x squared. We're not going to This one actually doesn't simplify at all. So I get x squared. Poor network quality. Oh no. I hope my video doesn't die on me.
That would be
I
sad.
just got a message on my iPad.
Mhm.
So
You kind of broke up just a little bit, but we're following you.
yeah. Well, Tracy's watching a video. There's nothing I can do. We'll talk more about how to simplify a problem like this later when we get into some of the concepts of polynomials and factoring and rational functions. That's more to come. Okay?
I might make one comment here because I do think it might be important to say when we define a function with division, we also need to define the restriction.
Mm-hmm.
We're going to talk a whole lot more about this later, but when I use division and I put x in the denominator, I've created a number or maybe multiple numbers that will no longer work. So I see in these original problems, there's no division by x. And then all of a sudden we have division by x down here in our new problem. So remember, we've talked about this on almost every video now. Division by 0 is a big no-no. So just kind of watch out for that. If I were to plug 3 in at this point in the denominator, 3 minus 3 would be 0, and so I would have division by 0. So I'm just going to say it's this, but also x now can't be 3.
Yep. Okay. So anyway, now we're happy.
He might not have wanted to tell you that, but I wanted to tell you that.
You go on with your bad self. Okay. I wonder if they're sick of me using pink yet.
No.
No? Okay. Because I like pink. All right.
I don't like that you're using this theme with pink, though. Like the orange and pink combo isn't great for me.
Well, we'll have to work on that in future lessons, I suppose. So, all right. Moving on. The last thing that's kind of a little bit out of left field, but it's kind of a precursor if you are possibly taking calculus, is something called the difference quotient. And I used to be a calculus teacher in a former life, and so was Miss Young at one point. The difference quotient allows us to find what's called the average rate of change. On these guys that bend and wiggle, they don't have a constant rate of change or a slope like like the line that you studied a lot in Algebra 1. So the slope of a wiggly graph or a curved graph can be approximated by what's called a secant line, where you pick 2 points that are kind of close together and they find a line between them. And if I zoom really in on that, it's almost indistinguishable, and you'll learn more about this if you take calculus.
So all of that was pretty mathy. Let me see if I can put it in some context for you. Imagine starting at 0 and you're driving. What's happening here is your speed is increasing, right? And so let's say from 1 minute to 2 minutes to 3 minutes, your speed is increasing and increasing and increasing. Well, we want to know what was your average miles per hour between 2 and 3 minutes, but your speed was increasing. So it's not going to be the same. But we can get an average, like maybe it started off at 25 miles an hour and it ended at 35 miles an hour. So the average was maybe 30 miles an hour. So that's what this does. It gives you that average.
So anyway, okay. And basically,
I don't know what all he just did. The screen was going crazy.
I'll zoom in on that little straight part, show you that like between these two dots, the blue line and the green line are really, really close to each other. And it's an approximation. It's an approximation of how fast you might be going at any moment in time when your speed is changing. This formula. Okay? And that's basically the slope formula. So let's look at the difference quotient for a function. Okay? And I'm going to, this is new to us, I'm going to take this and I'm going to copy it onto our slide so I don't have to write it again. How about me being smart?
So I don't know how he planned to do this because we didn't talk this out ahead of time because we're not very smart sometimes. But the way that I always think about it, if you get confused, is you're really wanting to find a couple of things and then put them together. Okay. So the first thing that you might want to find is f of x plus h. So, Mr. Bobby, you want to do that first? That first
You
step?
want to do it off like to the side, or do you want to do that?
Wherever.
Okay. All right.
I'll adjust around.
So we're going to do f of x plus h. So we haven't done this, I don't think, where I have something in there. We've done it where we've had letters in there, but what if I had something in there like, if it was a 2, I had to put 2 in the equation, right? And if I had 7, I put 7 in the equation. If there is an A, I put A in the equation. Well, if there's Bob, I put Bob in the equation. Well, now it's x plus h. So I'm going to put x plus h in place of x. So I'm going to go here and do x plus h in place of x. And that's part of the confusion is I replaced x with x plus h. So I'm going to lay it in parentheses like that, and then minus 3.
Minus 3, yep.
Now watch out. Oh my gosh, for the love of all that is good and holy, that's not x squared plus h squared. That's x plus h times x plus h. We would actually have to multiply that out like we just did in the previous problem. So I really have x plus h.
So remember, to square something means to multiply it by itself. And if we multiply x plus h by itself, then we've got that double distributive property happening.
It's almost,
you're going to get it wrong if you just try to square x and h.
It's almost like I knew what I was doing.
It's weird.
Okay, so I would get x times x times h times x, and then h times x. H times h, I'm sorry. I know that made perfect sense to everybody, but I would end up with x squared plus xh plus x plus h squared minus 3. Is xh different than hx? Nope. So those are like terms. I could combine them, and that would be 2xh. And now I don't have any other like terms.
Right.
So we need to.
So
that's f.
Yeah. Why don't we fill that in? So we have x squared plus 2xh minus 3. Now that's our first part. Now what we just did here is we found only this part of this formula, only the f of x plus h piece. There's a whole other couple pieces here. So now we got to wonder, like, what's f of x? Well, this is easy. What's f of x, Mr. Bobby?
It's right there. You got it in the box.
Okay. So I'm going to determine what f of x is, and then I'm just going to use it to do the next part, right? So I know that f of x is, I've just lost my whole annotation. I don't know what happened. There we go. Is x squared minus 3. I know this seems like a weird step, okay? But what I'm doing here, what I'm attempting to do here is walk you through what's happening in this formula. Identify f of x plus h. Identify f of x. And then once you have those two things identified, then you can go to your third step, and actually you can just write f of x plus h minus f of x and simplify.
So I'm going to take this part minus this part. And I probably shouldn't highlight it in the same color, but it's super pretty. What's going to happen when I subtract the first thing I highlighted, let's subtract the second thing I highlighted from the first? Some things might go away, won't they? Well, the x squareds will go away, right? What about the minus 3s?
I would guess when I subtract minus 3 from itself, it goes away.
That's what I would hope. So that's really kind of, if we break this apart and try not to freak out too much about this, the x squareds go away, the 3s go away. All that I have left is 2xh plus h squared. So Miss Young is writing all that down. And this is where when you subtract, you actually need the parentheses. Or you could,
If I write it like this, I'm going to get -6. But we just talked about if I subtract -3 from itself, it goes to 0. This is where that, like, anything that comes after the minus sign, if you're subtracting more than one thing, it really matters. Those parentheses really matter. But guys, if you do this right, then everything in the second parentheses should subtract away something in the first parentheses. So in this case, you've got that x squared minus x squared, and it's gone. And you've got that -3 minus -3, and it's gone, leaving you with 2xh plus h squared. And then our very final step, I've just changed colors here, but I don't think you guys mind, is divide by h. So that's us doing this final part, which is this big old division sign over h.
now, I just said we weren't going to worry about this. But I have something that happens. I have h's in the top and an h in the bottom. So I can divide everything by h and take away an h from both of the terms in the numerator. And all I would be left with is 2x plus h.
So there's 3 pieces here, 2xh, h squared, and h in the bottom. And what he's saying is all 3 of these pieces have this common h. And so because all 3 pieces have a common h, we can just remove that common h, and we're left with 2x plus h.
Okay. So that completes lesson 2.2. And the practice problems are on the next page. And 17b is no more important than any other. So we'll clear that up. So thank you for all your hard work. And if you need us, holler at us. We'll see you the next time.
Practice, 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 guys.